Welcome to qnawire.
Hi, so over here we're given a reaction at a temperature of 525 Kelvin, in which we're going to have 2 of H2S plus SO2, which produces 3 of sulfur as a gas, plus 2 of water as a gas. Over here, SO2 is also in gas form, and H2S is also going to be in gas form. So we're given that the delta H for the reaction is equal to 559 kilojoules. The delta S of the reaction is going to be equal to 222 joules per Kelvin. In this case, there's probably a typo in the question because the value provided is 222 Kelvin over Kelvin, so it could be kilojoules per Kelvin or joules per Kelvin. So over here, please correct as it should. I'm going to assume right now that it is going to be kilojoules per Kelvin, and there was just a missing joule over here on your units. And with this, we want to know what is going to be the value for the equilibrium constant. So in order to do so, remember that the equilibrium constant is going to be related by the value for delta G. Thus, the equilibrium constant is equal to the exponential of minus delta G standard over RT. The value for delta G is going to be equal to delta H minus T times delta S. So actually, over here, it makes more sense that the value was provided in joules per Kelvin. So I'm going to leave it like that. So the value for delta H would be equal to 559 kilojoules minus the temperature, which corresponds to 525 Kelvin, times delta S, which is 222 joules per Kelvin. Over here, I'm going to convert it directly into kilojoules by dividing by 1000. So the delta G standard for this reaction is 442.45 kilojoules, corresponding to 442,450 joules. So this is the value that we're going to employ into our calculation of the equilibrium constant. The equilibrium constant would be equal to the exponential of minus 442,450 joules divided by the value for R, which is 8.314 joule per mole Kelvin. Over here, the joules correspond to 1 joule for 1 mole of reaction. So over here, the value is given generally in joules per mole, and the temperature that we're employing, which was 525 Kelvin. So this gives us a value of 9.485 times 10 to the minus 45. So this would be the final result in this case. Now, just as an example, if the value for delta S is 222 kilojoules per Kelvin, and there was a typo on your question, then the value for delta G would correspond to minus 115,991 kilojoules per mole of reaction. But this value, it actually doesn't make sense. That essentially means that the reaction is going to have an equilibrium constant as a super large value. So just verify the units for delta S and correct accordingly. But this is going to be your general procedure. Okay. Remember that this is implying that delta S is equal to 122 joules per Kelvin. And with that, it would be all. Thank you very much and have a good one.